So we have an overview of our equipment today. We are doing a 5 kVA 24 volt system, a hybrid inverter. So as you can see, the inverter has got the bottom where the two cooling fans are situated. Then we also have our termination points for cables for AC in, AC out to the loads, and your solar termination point. Then you have your battery termination points. We have our on-off switch. On the sides, we've got these removable dust covers, one of them which I removed earlier. It's got a filter which you can clean for adverse conditions. These units have the capability of being installed even outside, so long as they are protected from direct sunlight and direct moisture like rain. You can install them outside if you prefer. So we are going to open the inside so that we can appreciate the internal. So for you to do the cable terminations, we have to open the lower bottom cover, which is this one that I've removed. Just 2 screws and it comes out. Then unless you are a professional, but if you know what you're doing, you can also open the top to check the internal components, how the architecture is done inside. Okay, there we go. Okay, so we can appreciate inside. The components are well laid out, such that in the event of a fault that requires someone to open and work on the unit, you really won't struggle to find the components. They are well labeled and the circuit board is well done such that the components are replaceable. This is a high frequency inverter, thyristor based. No wonder you notice that there is the absence of a big transformer. It's because this is a thyristor based unit. A very critical component that you need to pay particular attention to is the specs of the inverter. These are the specs that will guide you on how to connect your batteries, what voltage to go for, whether it is 12 volts, 24 or 48. It is also the same datasheet that is going to guide you on how you are going to do your solar panel connections, configuration, whether they are going to be in series or parallel. If you don't pay attention to that and you subject the unit to a higher voltage than it's rated for, you are likely to blow one or both of these capacitors. This happened to us in one scenario, and this is the capacitor that we had to replace. A goodness was only the capacitor was affected, and that's the goodness I've seen with this unit. A wrong connection does not mean you lose out on the whole circuit board and you have to replace the whole thing. You actually lose components that you can replace, and it was something that will be cheaply sourced and replaced, and the unit is working okay. Then the other advantage I've noticed with this unit, particularly here in Zambia, is the fact that as early as 0545, you will get an alert from the unit that it's detecting solar, and it will only stop detecting solar at 1840. Of course, keep in mind that your maximum solar input will be between 10 and 15 hours, but depending on weather conditions, even as early as 7. That is what I've noticed for the unit that I'm using. As early as 7, you have a maximum output from the sun, so long as you've got good sunshine, and by 16 hours your maximum will now start reducing until the sun goes down.